now. Okay, so we're recording the Zoom call. And let me go ahead and share my screen, and so I can just show you guys what is in Schoology. All right, so today is April the 5th. It is a Monday. Okay. And we are continuing our topic into projectile motion. Now, last week we focused on concepts in projectile motion. You know, we talked about the independence of X and Y, how whenever a projectile is launched on Earth, what's happening in the X direction is completely independent of what's happening in the Y direction and vice versa. So we're going to use those concepts today to do this assignment, this mathematical assignment. As always, when I post something like this, it's your responsibility to show your work. Okay, and then once you guys show your work, there's going to be 5 questions. Once you guys show your work, you're going to take a picture of it, and then you're going to upload it here to the submission box that says projectile motion calculation submission box, and that will count as your grade. Okay, so that is what we're doing on today. We're continuing our conversation into projectile motion, but now we're focusing on the mathematics. Okay. Before I get into projectile motion, there's one thing that I want to say. Remember one of the things we talked about last week, that anytime you take an object and you drop that object here on Earth, you can guarantee that its acceleration will always be 9.8 meters per second squared, independent of the object's mass. Okay, so acceleration does not depend on the object's mass. I want to show this video to you guys because I think last semester, I think I showed this video clip to one of my classes, but I didn't show it to all of my classes, and I don't remember which class it was, so I'm just going to go ahead and just show it to all of my classes now. But basically, guys, this video clip proves to you all that if you drop 2 objects of different masses, that they're going to accelerate at the exact same rate. And here's how this video is going to prove this to you guys. Guys, in 1979, our astronauts went to the moon. And so the moon is the perfect place to try this experiment because there's no air on the moon, right? Because of air resistance on Earth, it tends to have an effect on the falling objects. But since there's no air on the moon, this was the perfect place to try the experiment. But basically what we see here, that this guy here, in one of his hands, he has a feather. In the other hand, he has a hammer. And as he dropped both objects, you're going to clearly see that they're going to accelerate at the exact same rate, thereby hitting the ground at the exact same time. So let's see that here.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his...
Okay, so did you guys see that both the feather and the hammer hit the ground at the exact same time? Now, by the way, I just want to be clear that on Earth, the acceleration of gravity is 9.8 meters per second squared. However, on the moon, it's 1.63. Because the moon is a much smaller mass than the Earth, the gravitational force is weaker on the moon. Therefore, the acceleration is smaller. Just thought I'd be sure I say that. But the point is still the same. Acceleration does not depend on the object's mass. Okay, so hopefully that makes sense. All right, let me stop sharing my screen. Okay, so on today, we're going to take these concepts and we're going to use them to apply them to a few mathematical situations. Oh, by the way, before we do the work for today, I'm just curious, how many of you guys got the chance to watch the Mythbusters video that I posted? That I posted in Schoology? Because remember last time we had the fire drill, and Angelina, yes, thank you for watching the video. Um, uh, but Angelina, it proved what I said, right? That if you fire a bullet at the same time that you drop a bullet, they're going to hit the ground at the exact same time, which is pretty cool. Yes, physics is beautiful. Physics is beautiful. I'm glad you watched it, Angelina. Did anybody else watch the video? Come on, guys, y'all didn't watch the video. It really was, Angelina. It's really cool to actually see it in real time. Yeah. Guys, if y'all haven't had the chance, please go back and watch that video that I posted in Schoology because it proved an important point. But thank you, Angelina, for watching it. It's really cool to see the physics confirmed. And the lights just went off in my room. Okay, there we go. They're back on. All right, so let me open up the assignment for today, and I'm going to walk you guys through this assignment. So be sure you have pen and paper, or pencil and paper out. Okay, now guys, whenever we're working on this assignment, you guys do not have to worry about drawing the pictures. Basically, all you have to worry about is just showing me your work. And of course, when we get to that, I'm going to show you guys what you need to write down. I'm going to go over a few of these with you all. And as always, the rest you're going to do on your own, but you're turning in everything. So be sure you're copying along with me. Okay. Number one, let's look at number one. Number one says a ball rolls with a speed of 2 meters per second across a level table that is 1 meter above the floor. Upon reaching the edge of the table, it follows a parabolic path to the floor. How far along the floor is the landing spot from the table? Okay, so guys, let me draw a picture of how this problem is going to look like so you guys can get a feel for it. So on number one here, let me draw a picture. So we have a ball that's rolling across a tabletop. So let me draw my little table. Okay, so here's my tabletop. Here's my floor. Okay. So let us imagine we have a ball. Okay. And this ball is rolling along, as it says, the ball is moving at a speed of 2 meters per second. And then upon reaching the edge of the table, it's launched from the tabletop. And obviously its path of motion is going to look something like this, right? It's going to look something like a half parabola. Okay. So, and again, this is number one. Okay. So the question asks, how far along the floor is the landing spot from the table? So in other words, guys, what we're being asked to solve for in this problem here, by the time this ball lands, we're looking for the distance the ball traveled from here to here. In other words, we're trying to find what is the displacement of the ball in the x direction. Okay. So that's ultimately what we're looking for on number one. Okay. And again, guys, y'all don't have to draw the picture. I'm just trying to give you guys an idea, a feel for the problem. But we're trying to solve for the distance in the x direction. Okay. Now, guys, in order to do this problem, guess what we're going to have to use? We're going to have to use our kinematic equations that I gave you guys at the start of the year. If you guys remember, and let me pull up those equations now because I want you guys to remember how they look like. Guys, do you guys remember these equations from last semester? Do y'all remember these equations? The four kinematic equations? Awesome. Well, these are the equations we're going to need for today. However, for this assignment, we're going to only need one of these equations, and it's going to be this equation right here. I'm going to circle it. This is the only equation we're going to need today for our assignment. Okay. So, if you guys remember, in this equation right here, delta x stands for displacement, right? So, an object's displacement is equal to its initial velocity multiplied by time plus 1/2 times acceleration multiplied by time squared. Okay, so this is the equation we're going to be using today. This is the only equation we're going to be using for these 5 questions. And of course, I'm going to walk you guys through this process. So yes, Angelina, there is math today. Sorry. Jeremiah, you don't want to deal with math today. Angelina, I forgot, what does this symbol mean again? That's the crying symbol, right? That's right. I have to, I forget these things. The way you said sorry. I was just preparing you guys ahead of time, Stephanie, because there will be a lot of math today. But it's not hard. Once you guys understand my reasoning, it's not hard. It's kind of tedious math, but you guys get the hang of it. All right, let me see. Going back to now, pre-cal tomorrow. Yeah, I'm a goner. You'll be fine, Angelina. You'll be fine. All right, guys. So let's guys, let us look at everything that they gave us in the problem. Notice what it says. It says the moment the ball was rolled from the table, it was launched with a speed of 2 meters per second. So we're given the initial speed of the ball the moment it was launched. So guys, the moment this ball was launched in this direction, its initial speed was equal to 2 meters per second, right? So the initial speed is 2 meters per second. Okay? So that's how fast the ball was moving the moment it came off the surface of this table. Okay. It says the height of the table is 1 meter. So guys, I'm gonna write that down. So the height of this table, in other words, guys, the distance in the y direction, is equal to 1 meter. So that's the height of the table. Okay. So guys, we are given enough information here in order to solve for this horizontal displacement. Okay. So that's our goal. We're trying to understand the moment this ball is launched from the surface of this table. Using this information, we're going to figure out how far it goes. So everybody understand what we're looking for? Number 1, we're just looking for the displacement in the x direction. We're looking for how far it goes. All right. Okay. Now, guys, whenever you guys are working out this the math here, here's what I want to tell you guys. The most important thing to remember is that you're treating the x and y components as if they are independent of each other, right? So whatever's happening in the horizontal direction has no impact whatsoever on what's happening in the vertical direction, and vice versa. So you're treating those as if they're separate things. Okay. So with that said, I'm going to open up a new sheet of paper here. Now, guys, I'm about to start working out the process. This is when you guys start writing everything down. Again, you don't have to worry about drawing the picture, but you do have to show your work in order to get full credit. Okay. So again, on number 1, remember what I said.
I have a question.
Yes.
Sorry for interrupting. Is this number 1 like on the actual assignment?
Yes.
All right.
Yep. Yeah, I'm working on this problem right here where it says how far along the floor is the landing spot from the table. In other words, we're trying to solve for the displacement of the ball in the x direction. Okay, that's what we're trying to solve for. Okay, so we're concerning ourselves with two things. We want to know what's happening in the vertical direction, as well as what's happening in the horizontal direction. So remember what I said, guys. Ultimately, we are trying to find this displacement, right, in x. That's ultimately what we're trying to find. Okay. But guys, before we can even do this, guys, the first step we need to do in all of our problems is to solve for the time in free fall. That's the very first step that we're going to do. We're going to solve for the time in free fall, and we're going to use our vertical components to solve for that. So that's the first thing we're going to do. Even before we can do anything else, we're going to solve for the time in free fall. Okay. So that's the first thing we're going to do. Again, guys, whatever I'm writing down, please be sure you're writing down. All right, and I'm going to try not to move too fast. If I'm moving too fast, please let me know, and I will be sure to stop. Okay, so in order to find the time in free fall, guys, let's focus on the vertical component first, because remember, the vertical component is independent of the horizontal component, so you can look at them separately. So, guys, using our equation for displacement, and I'm going to write that equation down. So, an object's displacement in the y direction is equal to initial velocity multiplied by t plus 1/2 times acceleration multiplied by t squared. Okay, so remember I told you this is the only equation we're going to be using today for our assignments, and we're going to be using our displacement equation. Now, I know this said delta x before, but I'm just going to use d to mean displacement. Just know that they mean the same thing. In this case, d just means displacement. This specifically displacement in the y direction. Okay. Now, guys, this equation right here is going to enable us to solve for the time in free fall. Before we can plug in everything, I want you guys to think of something important here. Let me ask you guys a question. If I take a ball and I launch it from the surface of this table, the moment this ball is in the air, can someone tell me what do you think will be the initial velocity of the ball in the y direction? What is the initial velocity of the ball in the y direction? Okay, well, James, that's the acceleration in the y direction, but not the initial velocity. The acceleration is 9.8, but the initial velocity is what? What do you guys think the initial velocity is in the y direction? It's just 0. Exactly. Thank you, James. So the initial velocity of the y direction is going to be 0. So in the initial velocity in the y direction is just, let me just write this down, it's just 0. And guys, I want you all to think about why that is, because think about it. If I take an object and I release it, okay, at the exact moment that it comes out of my hand, its initial velocity at this point is 0. And then because of gravity acts upon it, then it starts picking up speed, right? But at that exact moment it comes out of my hand, the initial velocity is 0. Okay. So with that said, guys, if I plug in an initial velocity of 0 into this equation, like if I take 0 here and plug this in for the initial velocity, 0 times some number is just 0. So guess what, guys? Whenever you're dealing with the y direction, this part of the equation is going to go away, right? Because 0 times some number is just 0. So guess what? That means I'm left with this right here. The displacement in the y direction is equal to 1/2 multiplied by acceleration multiplied by t squared. Okay, right? There is no initial velocity in the y direction, so that's why this part of the equation went away. Now, guys, what I am ready to do, I'm ready to plug everything in and solve this equation for the time in free fall. Y'all follow me so far? I'm not moving too fast, am I?
All right. So how did you determine that wait, you said velocity was 0, right?
The initial velocity in the y direction will always be 0 on all these problems.
So are we all,
Always.
so,
In the y direction, it's going to always be 0. Because think about it, Jeremiah. You see my cell phone that I'm holding right now? Hold on. Jeremiah, you see the cell phone that I'm holding right now?
yeah,
The moment I dropped it, what was its initial velocity at the very top? It was just
in place 0.
0. And then gravity starts acting upon it, and it starts speeding up, right? But the moment it
Mm.
came out of my hand, the initial velocity was just 0. Okay. So in all of these problems, the initial velocity in the y direction will always be 0.
Oh, okay.
Yeah, always. And for these,
Vertical.
for the vertical direction, it's going to be 0.
So when we're solving for the vertical, we're always going to be taking out the part that you crossed out.
Yep, exactly. You're going to always cross out that part. Yep. Now, it's
All
going to be
right.
different in the x direction, but yes, in the vertical direction, you're going to always cross out that part. Yep.
Oh, okay.
Yes, sir. Now, okay, now, guys, let us keep going. So, I know the displacement of the ball in the y direction. Notice the displacement was a total of 1 meter. So, guess what I'm going to do? I'm going to plug in 1 into this equation. So, I'm going to plug in 1 into this equation. Okay. Now, James, what is the acceleration of gravity? It's just what here on Earth? Exactly, 9.8. Let me zoom in here. So I'm just going to plug in. I'm going to plug in 9.8 into this equation, right? Because here on Earth, the acceleration is always 9.8. Now, guys, I have everything I need to solve this equation for the time in free fall. Okay. Okay, now let's just solve this equation for t. We want to get t by itself. By the way, what is 1/2 times 9.8? In other words, take 0.5 and multiply by 9.8 in your calculator. What you should get is 4.9. Yes, thank you, Angelina. I was looking for someone to say that. 4.9. Thank you, Angelina. Okay. All right, so hopefully everybody's following me so far. Remember, our goal is to get t by itself. This is just algebra. Okay. Now, in order to get t by itself, guys, I need to do the opposite of multiplication. I need to divide by 4.9. So divide by 4.9. That goes away. Whatever you do to one side, I do to the other. So let's see what's 1 divided by 4.9 gives me. It gives me 0.204. And by the way, guys, I don't care how you round. If you want to round to the second decimal place or the third decimal place, it doesn't matter to me. As long as the answer is close enough.
Okay, wait, what did you do to get 0.204?
1 divided by 4.9. Yes, Angelina, that is an exact value. I just didn't want to write all that down because I'm lazy. I don't know what motivated you to type all that out, but I didn't feel like writing all that down. You want to be extra. You want to type everything out. Okay, but guys, can someone tell me how do I get rid of that square?
Don't you have to like do a square root?
Yes, do a square root. My bad. Let's do a square root. You're being precise. Okay, we'll use that term, being precise. being precise. I take you don't like the term extra, huh? Okay, well, you're being precise. Okay, we'll go along with it. All right, guys, what is the square root of 0.204? Okay, so guys, I'm gonna just round this to 0.45 seconds. Who's T? All right, guys. So I'm done dealing with the vertical component. So remember, I said you always want to start out finding the time in free fall. But yes, Angelina, that is the precise answer. Okay. But I'm not done though, guys, because remember, ultimately I wanted to find the displacement in the x direction. Okay, but hopefully everybody's following me so far. Okay, so in just a moment, guys, you're going to see why it was important that we solve for the time in free fall first. Okay, now that we've looked at the vertical direction, let us look at the horizontal direction. Okay, so remember what I said. We're using the same equation in all these problems. So I'm going to write down my displacement equation for the x direction is equal to initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Okay, so we're using this one equation for everything. Okay. Now, while you guys are writing it down, let me ask you guys a question. The moment the ball was launched from the surface of the table, okay, are there any forces acting in the x direction? Are there any forces acting in the x direction? Yes or no?
No.
No, there are no forces acting in the x direction because we're ignoring gravity. I'm sorry, we're ignoring air resistance. Remember, gravity only acts in the y direction, but it doesn't act in the horizontal direction. So ignoring air resistance, there is no horizontal forces. So if there's no horizontal forces, that means our acceleration in the x direction must be what, guys? What must be our acceleration in the x direction if we're acting? If there are no forces acting there, the acceleration is just what, guys? For the horizontal direction. Thank you, Stephanie. It's just 0. The acceleration is just 0, right? Because remember, in the horizontal direction, our ball is moving at a constant velocity. So since it's moving at a constant velocity, its acceleration is just 0. So guys, if I take an acceleration of 0 in the x direction and I plug it in here, right? 0 times 1/2 times some number is just what? It's just 0. Exactly. So guess what? This part of the equation goes away, right? So in the horizontal direction, there is no acceleration, so this part of the equation just goes away. So guess what I'm left with? I'm left with displacement in the x direction is equal to the initial velocity multiplied by t. Y'all follow me so far?
Yeah.
Okay. And remember, guys, whatever the initial velocity is, that's the velocity the entire time because the velocity stays constant in the x direction for projectile motion. All right, guys. Now we have everything we need to solve for displacement of the x direction. Okay. So look, and the problem they told us our initial velocity was 2 meters per second. So let's plug that in. So we're going to take 2 meters per second. We're going to plug that in here. Okay. Can someone tell me what do we plug in for our time in free fall? What do y'all think?
The 0.45.
Yes, the 0.45. And think about that logically, because remember, this was the time in free fall in the y direction. But think logically here. If the ball spins 0.45 seconds in the air in the y direction, then obviously it also spins 0.45 seconds in the air in the x direction. So our time is just 0.45 because we already solved for that. Okay. So can someone tell me when I multiply those two together, what do I get for the displacement in the x direction? What do I get? What's 2 times 0.45? Thank you, Angelina. Is 0.9 meters. There you go. That is your final answer for number 1. Well, that is your answer for number 1. Okay. So I'm gonna zoom out so y'all can see that whole thing. That's how you do number 1. Any questions?
So there's only one answer, and that's the D.
Yep. Right, because
Okay.
that's what it asks you to find. The displacement in the x direction.
So if they ask you to find the displacement, never mind.
I'm gonna walk you through how to do the rest, Angelina. I'm gonna walk you how to do the rest, Jeremiah. Yes, Angelina, it is a lot of work, but once you get the hang of it, it's not gonna be that bad. But yeah, Jeremiah, I'm gonna walk you how to do the rest. Hmm. Stephanie, read the problem. What does it say? The table is 1 meter above the floor. So Stephanie, they gave you the height in the problem. You're good, Stephanie? Yeah. If you read the problem, they gave you the height. Okay. Any questions on number 1 before we move on? I know it looks like a lot, guys, but once you get the hang of it, it's really not that bad. It's really not that bad. Stephanie, it looks like a lot. It's not that bad, I promise. Besides, yeah, I only have 5 problems, so it's not too bad. Okay, guys, any questions on number 1? By the way, guys, Stephanie, you'll be fine. Angelina, it'll be fine. Um, by the way, guys, number 2 is just like number 1, so I'm going to skip number 2 and I'm going to work out number 3 with you guys because number 2 is just like number 1. By the way, I want to, even though I'm going to skip number 2, I'm going to show you guys how number 2 looks like, how the picture's going to look like. So on number 2, I'm going to read this. It says, number 2 says, a rescue pilot drops a survival kit while her plane is flying at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If air friction is disregarded, how far in advance of the starving explorer's drop zone should she release the package? Basically, guys, on number 2, they're asking you to solve for the displacement of the x direction. So that looks something like this. Let me just show you guys a picture of how number 2 looks like. And again, this video is going to be posted on YouTube, so y'all can go back and look at it later. But guys, basically on number 2, your picture is going to look something like this. So this is how your picture should look like for number 2. Right. Because think about it. Because think about what it says. It says an airplane is dropping a package. So the moment the package comes out of the airplane, its motion is going to look something like this, kind of like a projectile. So it's asking you to solve for this distance right here, this displacement of the x direction. In other words, the displacement of the object. The displacement of the object from the moment it's released from the airplane all the way until it lands on the ground. So you're looking for the displacement of the x direction. They give you the height, how far the airplane is above the earth. So they give you the speed of the airplane. So they give you everything to solve for displacement of the x direction. In other words, guys, you're going to do number 2 exactly how you did number 1. Just like how we did number 1, that's how you do number 2. But that's how your picture looks like. Okay.
Does it give the displacement of the y?
It does. It does. See, look at the problem. The displacement in the y direction is the height. So look at number 2. It says the altitude is 2,000 meters. So the altitude is your y displacement because that's the height. You got it, Jeremiah, for number 2?
Yeah.
Okay. All right. But here's what I want to do. I want to do number 3 with you guys. So let's do number 3. Let's open up Kami. Okay, number 3. I'm going to read number 3, and then I'm going to draw a picture. And then we're going to start doing the problem. Remember, y'all don't have to draw the picture. The picture is just to give you guys an idea what's happening. Okay. Number 3 says, a rifle is fired horizontally and travels 200 meters. The rifle barrel, the rifle barrel is 1.9 meters from the ground. What speed must the bullet have been traveling at? Okay. Ignore friction. Okay. So let's draw a picture of this. So let's draw a picture of number 3, how this looks like. So off to the side here, I'm going to draw my rifle. So, okay. Guys, here's my rifle. Okay. That's nice. That's a nice looking gun right there. Okay. So we have our rifle on number 3. Okay. So we take the rifle and we fire it, and the bullet is obviously going to go something like this. Okay. And eventually, at some point over here, the bullet's going to hit the ground. At some point. Okay. So at some point, the bullet's going to hit the ground. Okay. All right. So on number 3, it tells us the bullet is fired horizontally and it travels for 200 meters. So guys, if it travels a total of 200 meters, that means the bullet in the x direction from here to here has a displacement of 200 meters. Okay, so they give us, number 3, they give us the displacement of the bullet. Okay. Let's see what else they give us. They says the rifle barrel is 1.9 meters from the ground. So guys, 1.9 meters is the height of the rifle. 1.9 meters is the height of the rifle. So we're given, so the distance from here, basically the distance from here to here is 1.9 meters. So I'm going to write it down. So distance in the y direction is equal to 1.9 meters. Everybody follow me so far? So that was given in the problem. 1.9 meters is how high the rifle is from the ground. Okay. So I'm just drawing a picture. Okay. Now, guys, what does the problem says? It says what was the speed of the bullet traveling at from the moment it was released from the rifle? Guys, in other words, we're trying to solve for the initial velocity in the x direction. That's really what we're trying to solve for in number 3. That is the goal. Okay. And we're given all the information to solve for that. That's what we're trying to solve. We're trying to find the moment this bullet was shot from this rifle, what was its initial velocity in the x direction? Okay, that is the goal. Okay, so hopefully everybody's following me. Again, you don't have to draw the picture. The picture is just to assist you, to give you to a visual of what you're looking for. Okay. Now, guys, in order to solve this, remember, you're treating x and y as if they're independent of each other. You're focusing on one thing at a time. Okay, so let me go ahead and pull up Kami. Now, this is where you guys need to be showing your This is where you guys need to be showing your work. Again, we're on number 3. Okay, again, we're treating the vertical component as if it's independent of the y component. So we're going to look at the vertical component first. And then we're going to look at the horizontal component. Okay. Excuse me. Okay. Remember, guys, ultimately in number 3, we're trying to find the velocity of the object in the x direction. Okay. But before we can do that, guys, remember what I told you guys. In all of these problems, the first thing you want to do is that you want to solve for the time in free fall. It's the very first thing you want to do. You want to solve for the time in free fall. In other words, how long is the bullet in the air? So we want to solve for the time in free fall. That's the first thing we want to do. Which means, guys, we need to use our displacement equation, because this is the same equation we're going to use. The displacement in the y direction is equal to initial velocity in the y direction multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Okay, so that's the equation we're going to use. Okay. All right, so remember, the first thing we need to do is to solve for t. The first thing we need to do is solve for t. Hey, Joe, but let me call you back later, okay? Because I'm in the middle of listening. All right, bye. Okay, so first thing we need to do, we need to solve for t. Okay, now, guys, what did I say? The moment this ball is, not ball, but bullet, the moment this bullet is fired, what is its initial velocity in the y direction? Someone tell me. At the precise point that it's launched from the bullet, yes, Stephanie, its initial velocity is 0. Okay, the initial velocity is going to always be 0. Yes, Angelina. Because think about it, because the initial velocity is 0, and then gravity starts acting on it, and it starts to accelerate. So the initial velocity is just 0. Okay. So guys, if I take 0 and plug it into this equation, like if I literally take 0 here and plug that in there, 0 times some number is just 0. So guess what? This part of the equation right here goes away, and I'm just left with displacement is equal to 1/2 multiplied by acceleration multiplied by time squared. Okay. So hopefully everybody's following me. All right, guys. Now, what we need to do is we need to just plug in everything to solve for t. Okay, so we're given the height of the rifle above the surface of the earth is 1.9 meters. So obviously the vertical displacement is just 1.9 meters. So I'm going to plug in 1.9 meters for the distance of the displacement in the y direction. And obviously the acceleration of gravity is just 9.8. All of that multiplied by t squared. And again, guys, hopefully everybody is following me. Okay, I'm going to let you guys finish writing it. Remember, our goal is to solve for t. Our goal is to get t by itself, the time in free fall. Now, we all know what 1/2 times 9.8 equals. 1/2 times 9.8 equals 4.9. So I'm just going to take this equation and reduce it. Yes, Stephanie. 4.9. All of that multiplied by t squared. Okay.
Wait, how did you get 1.9 again?
How did I get what? 4.9? Oh, 1.9? That was given in the problem. The rifle barrel is 1.9 meters from the ground. So that's the height of the rifle barrel.
Okay.
Yeah, it was given in the problem. Oh, excuse me, I'm getting sleepy. Okay, now, all right, guys, remember our goal is to solve for t. So I'm going to divide this by 4.9. That goes away. Whatever I do to one side, I have to do to the other. So what is 1.9 divided by 4.9? Yep. That is right. Come in.
Hey, Mr. Taylor.
Yes, sir.
I'm going to put a student in here for a few minutes. I'm going to run to the restroom right quick.
That's fine. Yeah, that's good. All right, guys. So this is point.
Is your door unlocked?
3. No, it's not. Yeah, just you can come through here.
Huh?
You can bring them through here if you want.
Okay.
So 0.388. Just going to round that. And then how do I get rid of that square? Just take the what?
Square root.
Yes, sir. Yes, Stephanie, you are correct. And again, guys, I don't really care how you round. If you want to round to the second decimal place or the third decimal place, it doesn't matter to me as long as your answer is close enough. I'm more looking for the process that you did the process right. Okay. All right, guys. So that was our first step. We had to solve for the time and free fall. It was 0.62. So 0.62 seconds. Let me be sure I put my units. We're almost done, guys. With this one. So I'm gonna put 0.62 seconds, right? Because that's time. Okay, so I'm gonna zoom out so you guys can see that 0.62 seconds. That's the time in free fall. Okay. All right, guys. Now I'm ready to move on to my horizontal component. Remember, I said you can treat your vertical component as if it's a separate thing from the horizontal component. You can focus on one thing at a time because those are the rules of projectile motion. Okay, so remember, guys, in every situation you're using you're using your displacement equation. So the displacement equation says, in this case, since we're dealing with the horizontal direction, we're dealing with the x displacement. It's equal to the initial velocity multiplied by t plus 1/2 times acceleration multiplied by t squared. Okay. Question, guys. Does this object right here has any acceleration in the horizontal direction?
Nope. So you cross it out.
Exactly. Yeah, there's no acceleration, right? Because in fact, the object's moving at a constant velocity, right, in the horizon. There's zero acceleration. There are no x forces. And again, the assumption is we're ignoring air resistance. There's no x forces acting here. So if I literally was to take acceleration of zero, because there's no no x forces means zero acceleration. So if I plug in zero this equation, zero times some number times 1/2 is just zero. So you're right, Jeremiah. I can just cross this part of the equation out, right? Because there's no acceleration for the horizontal direction, none whatsoever. So I'm just left with this, that the displacement in the x direction is equal to the initial velocity multiplied by t. And of course, this initial velocity stays constant. Okay. All right, now guys, I have everything I need to plug in to solve for the initial velocity of this gun here. What is initial velocity the moment it was shot from? The initial velocity of the bullet the moment it was shot from the gun. So let's just do that now. Okay. So we know that the bullet has a displacement of 200 meters in the x direction. So I'm going to plug in 200 meters. Can someone tell me what was the time in free fall for the bullet? What is the time in free fall, guys? Yep, 0.62 seconds, right? Because if you think logically, if the bullet was in the air for 0.62 seconds in the y direction, then obviously it had to be in the air for 0.62 seconds in the x direction. So I'm gonna plug in 0.62 in this equation for time. Okay. Now, guys, can someone tell me how do I get initial velocity by itself? How do I do it? I have to do the opposite of multiplication, which is what, guys? Divide. Thank you, Stephanie. So I'm going to divide this by 0.62. That goes away. Whatever I do to one side, I have to do to the other. So let's see what I get there. So guys, that's what I got from my initial velocity, 322.6 meters per second. Okay, so that is number 3. Any questions?
So number 3, you're solving for the velocity.
Yep, you're solving for the velocity because in the problem they asked you to find the speed, which is the same thing as velocity.
Okay.
So
And they
again,
gave you the displacement, which was the 200.
yep, they gave you displacement. Yep. You have to solve for the time and free fall, and then there you go. And of course, guys, this is the only thing you have to have written down for number 3. You don't have to have the picture drawn. If you want to draw the picture, that's fine. It's totally up to you. You don't have to, but hey, if you want to, that's great. And if you guys notice, if you go to the worksheet, if you notice, out to the side here, they give you the approximate answers to the problems. Of course, we saw we got 322.6, but they said it was 321. Guys, as long as you get something close enough, that's fine. Because remember, guys, we were rounding anyway. So if you get something that's close enough, you know, within the few points, you know you did it right. Obviously, if you get something way off, you did something wrong. But they give you the answers so you guys can kind of check yourselves. Because remember, the biggest thing that I'm grading your process. I'm grading your process to be sure you did everything right. Okay, when I grade through this. But any questions on number 3? Yeah, it's Angelina. It's really not that bad, is it? Once you did it a second time, it wasn't that bad. Yeah, it's just 5 questions just like this. It's not. It's once you get the hang of it, it's not bad at all. Yeah. It just kind of looked like a lot at the beginning. Yeah, you're good. I know you would feel that way. Once we did a second one, I knew you would feel that way. Stephanie, it's not that bad, right? Because you were just like, man, that's a lot. Awesome.
So we're doing another one, right?
Um, not as a class.
Are you sure about that?
Not as a class, but guess what I decided to do? I decided to help you out a little bit. Let me show you. Okay. So we done 2, so really there's only 3 more that you have to do. But guess what I was nice enough to do? I actually
Laying 70.
I actually posted number 4 on my YouTube page. So if you go on my YouTube page, I actually worked out number 4 with you guys. And of course, the reason why I did that because number 4 is slightly different than number 1 and number 3, and the way you work it out. The concept is the same, but it's a slightly different process. So I actually work out number 4 with you guys on my YouTube page. So watch that YouTube video if you need help with number 4. But basically, the only ones you're going to be doing by yourselves are numbers 2 and number 5. Okay. And number 2 is just like number 1. Okay, so you guys should be good. Okay. Not a problem, Jeremiah. Anthony said, what is number 5 like? Number 5, let me see. What number 5, you're looking for the horizontal distance. So that means number 5 is still like number 1 too. Yeah, it's just like number 1. So, but I will say this though on number 5, guys, this is very important. Look on number 5. By the time you guys get to number 5, notice what it said. It said that the object is on the moon, right? So the object is on the moon, right? Because it says the astronaut throws it off the edge of a lunar crate. So he's on the moon. Okay. So guys, the acceleration on the moon is not 9.8. That's the acceleration here on Earth. Notice what they tell you. They said the acceleration of gravity on the moon is 1/6 of that here on Earth. So basically, guys, if you take 9.8 and divide it by 6, okay, yep, exactly, it's 1.63. Yeah, so on the moon, the acceleration will be 1.63 meters per second squared. So and that's solely for number 5, right? And all the other problems you're going to use 9.8 because you're here on Earth. But when you're on the moon, you need to use a different value for your acceleration. Just something to keep in mind. All right. Thank you, Angelina. I appreciate you guys too. You guys are some awesome students. You are good kids. Makes my job easier when I have good kids. All right. So, any questions? Any more questions? Again, number 4 is worked out for you all. Number 4 is worked out for you all. Just use the resources available to you all. Yeah, I pretty much covered everything. And plus, this video is going to be on YouTube. Let me go ahead and stop recording so I can get ready to post it.